Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. My name is Siti Ala. Thanks for the chance given to me. In this time, I will explain about our research. The title is New Techniques for Improving the Quality of Cotton Yarn Using Natural Dyes from Thick Leaves, Tectona grandis, Ketapang leaves, Terminalia catapa, and Banten tree skin, Lanea coromandelica. We are from Physics Department, Universitas Mataram, West Nusa Tenggara. Introduction. The tourist sector is one of the main income sectors for the island of Lombok. Sade village is one of the Lombok tourist villages. This village is famous for its strong custom, such as coloring woven fabric using traditional methods. Before doing the coloring, the local community does a sizing process on the cotton threads that have been spun with rice soaking method. This process can increase the tensile strength of the yarn. Besides that, the coloring process utilizes the plants around the home environment. The plants used include thick leaves, ketapang leaves, and banten skin. This type of plant is abundant and easy to live in dry areas. Every plant has a source of natural dyes because they contain natural pigments. The potential source of color produced depends on the type of dye present in the plant. We can obtain dye from plants by extraction and fermentation. Apart from fastness resistance, yarn quality can also be seen from the physical properties of the yarns, colors, and the tensile strength. Increasing the strength of yarn will significantly affect the quality of the weaving produced. Therefore, it is essential to analyze the physical properties of the yarn from natural dyes. The strength of the yarn and the resulting color affected by pH level, the concentration of the solution, the type of plants, and the extraction method. In this study, the measurement of yarn quality improvement using natural dyes was carried out at different pH, concentration, and plant species. Methodology. Coloring stage. The natural dyes used here are thick leaves, ketapang leaves, and banten skin. Preparation is done by cutting it into size 1 cm cross 2 cm. The cotton thread preparation was carried out by separating the threads per strand and cutting them to a size of 15 cm. Then the threads are tied together. The coloring process is carried out in 3 main stages: mordant, dyeing, and fixation. The mordant stage uses 8 grams of alum. Alum is dissolved in 1 liter of distilled water. Cotton threads are soaked for 12 hours in this solution. After soaking, the threads are dried in the sun to dry. The next stage is coloring using natural ingredients. The dyeing is carried out in 2 processes: the manufacture of dyes and the dyeing of the yarn. The dyeing process was carried out by the extraction method. The dye was added to distilled water with a mass ratio of 1/10, 1/8, and 1/5. Each material was heated to halve its initial volume. After the solution is ready, the next process is dyeing the yarn. The yarn was dyed with 2 variations of treatment, namely for 30 minutes and 12 hours. Furthermore, the threads are dried in the sun to dry. Then the final stage is fixation. The fixation solution is made with 50 grams of alum in 1 liter of distilled water. The threads are soaked for 5 minutes, then dried. The analysis of the quality of cotton yarn is then viewed from some aspects: the colors, the tensile strength in each dyeing stage, and the tensile strength influenced by the acid-base properties of the dye solution. Yarn strength analysis was tested using Tensilon RTG 1310 with the ASTM D2256 standard. Meanwhile, the pH of the dye solution was tested using a pH meter. From the results, we can recommend the appropriate treatment in the coloring process. The results in this study, the dyeing process was carried out by two methods, namely immersion for 30 minutes and immersion for 12 hours. These two methods produce different colors. However, the resulting color difference was not significant. The 30 minutes immersion result had the characteristic of the color fading faster when fixed than the 12 hours immersion. This phenomenon occurs due to the acidic nature of alum as a fixator. In this study, thick leaves produce a dark brown color. This pigment arises due to the presence of anthocyanin content in thick leaves. From the image, we can see in 30 minutes of immersion, it is shown that the thick leaves produce a mellow brown color for concentrations 1/10 before fixation and milk brown color after fixation. At concentration of 1/8 and 1/5, the pigment was dark brown before fixation and mellow brown after fixation. Otherwise, in 12 hours of immersion, there was a change in color before and after fixation. Before fixation, a purple color thread is obtained, and after fixation, it becomes dark brown. The result of dyeing the threads with the colored pigment from ketapang leaves gives a turmeric yellow color. This yellow pigment appears due to the carotenoid content in ketapang leaves. In the 30 minutes immersion treatment, the yarn produced a golden yellow colors for 1/10 and 1/8 concentration, while the 1/5 concentration produced a turmeric yellow color before fixation. After fixation using alum, the color of the threads turned golden yellow, slightly faded at all concentration. At 12 hours of immersion, all concentration treatment produced medium yellow thread before fixation and saffron yellow after fixation. The brick red color of the yarn is produced by dyeing it with the skin of the bantan tree. This brick red color appears because the skin of the offering contains anthocyanin. Rose baby color for 30 minutes of immersion on the yarn was produced at all concentration of the solution before fixation. However, after the fixation process, the rose baby colors start to fade. The brick red color for 12 hours of immersion was produced before fixation, and the brick red color was medium after fixation at all concentration. From the three types of plants, the color produced at 12 hours of immersion was better. This phenomenon happened in all treatment before and after fixation. In general, the color results do not fade quickly when going through the fixation process. Soaking the yarn into dye for 12 hours is recommended to be applied to the weaving yarn. The yarn tensile strength test was carried out on the yarn with a 12 hours immersion treatment. Based on the data in the table, the tensile strength of the yarn is higher than before the mordant. The tensile strength of the yarn after dyeing and fixation tends to increase. This result happens because the fibers in the cotton thread are getting close together. Besides that, the difference in the solution concentration also affects the strength of the resulting yarn. A solution with a concentration ratio of 1/8 produces optimal tensile strength, namely 0.34 on thick leaves, 0.33 on ketapang leaves, and 0.24 on bantan skin. From the tensile strength result, we can see that the highest tensile strength occurs in thread colors using T-clips. Besides the type of dye and the concentration, the pH also affect the strength of the yarn. The higher the pH of the solution, the smaller or lower the tensile strength. The decrease in the quality of the yarn is due to the acid-base nature of the dye solution. That's all the results, and for the conclusions, teak leaves, ketapang leaves, and banten skin can be used as source of natural dyes. The treatment of yarn immersion in natural dye solution for 12 hours is better. Besides that, each dyeing process can increase the tensile strength of the yarn, and the optimum tensile strength was found at the concentration of 1/8. Of the three types of plants, teak leaves produce the maximum tensile strength. Besides that, the solution's pH also affect the yarn strength. That's all from me. Thank you very much.